Hi, I'm Guang, 15 years old, secondary through Friends High School. In this lesson, we have a new series, Limit Theory and its Applications. Alright, so limit theory and its applications, we will be starting from showing how some limits work using what you would call the epsilon delta method. Okay, so in this lesson, we have these two different examples. Now let's take a look at the first example, where we need to show that limit x approaches to 3, 5x plus 7 is equal to 22. So of course, if you take a look at either of these examples, it is easy to solve them. You just have to substitute the x in. But when you want to show why this is correct, you might not know, okay? So we're going to show you how you could use this epsilon delta method. So starting with the first example, when x approaches to 3, and let's say it is not 3, so it is somewhere around 3, it approaches to 3, it is close to 3. And when this is close to 3, that means it is not exactly 22. So whatever answer you get will also be close to 22. So these two will each have a difference, and one will be called epsilon, one will be called delta. So let's take a look at how this works. So what we would have is, let's say, given we have epsilon which is greater than 0, alright? So when we're given epsilon greater than 0, epsilon is one of the differences. And that means you have another difference which you could say there exists delta greater than 0, alright? So what exactly are these two differences? So 5x plus 7 minus 22, the difference between whatever value you get here and this tendency would have to be smaller than epsilon in order to think that whatever tendency you have is actually correct. Since if you give it a certain condition, like when it is in whatever range, then you'll consider it as correct. You could always find something within this range that fulfills your conditions, which you can keep on doing it, alright? So when you have this, then you have to be a little more aware of this part, since maybe it could be negative, maybe it could be positive, so it is rather safer. I did say safer, since some cases there will be positive and negative things. So 5x minus 15, and you have to modulus, and this is smaller than epsilon. So for this part, what you will have is you take the 5 out, you divide the 5 to the other side. So x minus 3 modulus is smaller than epsilon over 5. Right, so this is what you see. But what exactly does this mean? Now let's take a look at the limit. Limit x approaches to 3. So I did say just now there was another difference, right? Where you call it delta. So for your delta, it is the difference between whatever x value you take and whatever x value it approaches, which is 3. So that means your delta would be a x minus 3. But here you would have to write it as, let delta be equal to epsilon over 5. So that will be your difference in whatever you have, alright? So when the difference between these two values is smaller than epsilon over 5, limit x approaches to 3, 5x plus 7 is equal to 22. And this is the first example that you have. Right. Now this seems pretty simple, right? Since you just have epsilon and it becomes whatever delta you have. But how about let's take a look at the second example. It's a little more complicated. You just have an actual square inside. But will it make a lot more different? let's find out. So of course, in the second example, we will start off in the same way. Given epsilon greater than 0, let there exists delta greater than 0. Okay? Alright. So again, let's take a look at what needs to be smaller than epsilon. Well, you have your value 2x squared plus 11 minus 83, and this is smaller than epsilon, right? So this entire part here is smaller than epsilon. Let's simplify a little. 72. So then we divide 2 on both sides, then you realize this is x squared minus 36. Now how about we actually factorize that? Well, you have x minus 6 multiplied by x plus 6. Now why do we have to do this, you might ask? So even if it looks a little more complicated, what you have to realize is, what is your delta? Delta is x minus 6. So how about let's get x minus 6 right now. But wait, where does this other part go? Well, of course, it is divided to the other side. Alright, now that's our delta, isn't it? Wait, you can't just let this entire thing be delta, since delta and epsilon, actually both of them, we take them to be a constant. But if you have an x that is not a constant, that means we have to use some other method to try to convert it back and make it a constant. Now how, you might ask? So of course there are a few different methods. Whether you want to let delta be something first, let's say let delta be smaller than 1, and then you try to find out what x could be, and then use the x you have to find this x, and finally what delta could be again. Or you could also direct. So in this part, there are actually multiple methods which you could use, whether you assume delta to be something or whether you just assume this, but since delta and this are actually the same, so let's just say we let modulus x minus 6 be smaller than 1, okay? So that means x, you're going to see, is smaller than 7, greater than 5, okay? So this is x. Now I can find x plus 6. So whether you use modulus here or bracket here, it actually doesn't matter anymore, since x will always be positive, and a positive thing add on to a positive thing would never be negative. So this is smaller than 13, greater than 11. Now how about twice of this? It will be smaller than 26 and greater than 22. So now how about we take the reciprocal of it? So now it has become smaller than 1 over 22 and greater than 1 over 26. So in the previous question, we had this delta, which delta would be whatever you have for x minus 3 in this case. Well, here it will be x minus 6. So now, how do we determine this delta? Now, delta, so first of all, we will need to let x minus 6 be smaller than, so we take the smallest case, which will have epsilon over 26. So this is the smallest case. Now you see this and you might think again, would this just be our delta? Wait a moment first, since we also have another part that looks similar above. So that means delta, we will have to take the minimum between 1 and epsilon over 26. Okay? So now some of you might think it's definitely 1. Some of you might think it is definitely epsilon over 26. But this really depends. Since epsilon, it could be pretty much anything. It could be 1, it could be a decimal, it could be 26, it could be 100, it can be anything. But generally, we just have it approaches to 6, alright? But since in this case, it depends on what kind of a question you get, whether it gives you whatever epsilon value it is, alright? So, when x minus 6 with modulus is smaller than whatever delta you have, limit x approaches to 6, 2x squared plus 11 would be equal to 83. Alright, so this is what we have over here and shown. Alright, so now I hope that for these two examples you can pretty much understand them. Otherwise, I'm going to give a brief summary of what your thought process would be. So, your thought process, you would want to start from the difference between the final value you have, or whatever value you have, and its tendency. And this difference is called epsilon. So, by manipulating whatever we have for epsilon a little bit, you want to try to get the difference between the x value and whatever value x actually tends to, which in this case is x minus 6, and in this case it is x minus 3, alright? So, whatever x value tend to, then you have a delta. So, you will want this difference to be smaller. Well, as small as it can get, you have to be aware your delta should not be variable. So this is just constant. But then again, you might wonder, could this be 2? Could this be half? It can be anything you want to set it to, since it is pretty much like an arbitrary constant. It just depends on what you want to set it to. So in some cases you have more than one delta, but you just want to take the smallest. In this case at least, since you want to approach to whatever value you have. So let's say you want to say this value is whatever you want to consider as correct. Then you'll always be able to find a case where it is suiting whatever you have. So it's basically this when this is smaller than delta. So it's basically this case, alright? So when this condition is fulfilled, then it will be correct. So I'll just end this lesson here, and thank you for your watching.